Whew. All right, chemistry people. Question number 1 asks how many moles of water vapor can be generated from the combustion of 18.74 grams of ethanol. Really important before we do any sort of stoichiometric calculations that we have a balanced chemical equation that shows us the correct relationships that exist between our reactants and products. We've got a combustion reaction here. I'm going to start by balancing my carbon. So I'm going to put a 2 here that balances my number of carbons. I'm going to go next to hydrogen because hydrogen appears only once on either side of the reaction. I've got 6 on the reactant side, only 2 on the product side. So if I put up a 3 as a coefficient there, that'll balance out my hydrogen. And then as I look to balance my oxygen, I've got 4 plus 3, that's 7 on the product side, and I've got 2 plus 1, that's 3 on the reactant side. Again, if I put a 3, coefficient of 3 here, that'll balance my oxygens, and the overall equation is now balanced. So step number 1, make sure that you balance that chemical equation. Now we can try and tackle this problem. We're asked to determine again how many moles of water vapor can be generated from 18.74 grams of ethanol. So this is going to be just straight up dimensional analysis. You always want to start with your known amount, in this case the 18.74 grams of ethanol, the C2H6O. So we're going to go from grams of C2H6O to moles of C2H6O. From moles then of C2H6O, we can go to moles of our water vapor. As we think about how to determine the relationship between these two things, moles and grams, that relationship is found on the periodic table. So again, you're going to use C2H6O. You're going to sum together the masses of each of these elements. There's C, there's O, there's H. We need 2 carbons, 6 hydrogens, 1 oxygen. When you sum those together, you get a mass of 46.068 grams. For every 1 mole of ethanol. When it comes to the mole-to-mole relationships, we find that based on the balanced chemical equation. For every 1 mole of ethanol, we will make 3 moles of water. We recognize we've set our dimensional analysis up correctly because our units of grams, units of moles of ethanol will cancel out and we'll be left with moles of water, which is what we want. Then it's just a matter of plugging this into your calculator and solving. When we plug this into our calculator and solve, we get 1.220 moles of H2O. Again, we've got 4 sig figs to start with, so we want 4 sig figs to end with. Reminder that the conversion factors are not going to affect your number of significant figures. Boom. Now, as you're working through these problems, it's really important that you think about how you can estimate to solve these same problems. In the event that you're given a question like this in a multiple choice format, you won't be allowed to use your calculator. So as we think about this, I might estimate here, I've got 20 grams of the ethanol. I'm going to do a rough estimation here and say I've got about 0.5 moles of ethanol. Now again, that's a little bit on the heavy side, but again, I'm just here to estimate to make sure that my final answer is reasonable. And as you look at your balanced chemical equation, for every 1 mole of ethanol, you're going to get 3 moles of water. So if I multiply my number of moles of ethanol by 3, I get 1.5 moles of water as sort of my estimation. We got 1.220 moles of water, which is reasonably close. Again, we estimated a little bit on the heavy side, so this answer does indeed make sense. All right, moving on to question number 2. As we take a look at number 2, it says, in the reaction of lead 2 nitrate with sodium hydroxide, how many grams of sodium hydroxide are required to form 51.63 grams of lead 2 hydroxide? All right, now as we think about solving this problem, we should notice that we're missing a balanced chemical equation. So our very first step to solve this problem is to figure out what that balanced chemical equation might look like. If we remember our nomenclature, lead 2 nitrate here is going to look something like this. We're reacting it with the sodium hydroxide to form lead 2 hydroxide and sodium nitrate. Now, again, it's really important to make sure that not only you write the chemical equation with the correct formulas, but also make sure that your equation is balanced before moving on. This one is pretty straightforward. We can keep our polyatomic ions together as a unit because they appear on each side of the equation as polyatomic ions. And so as we take a look here, I've got 2 nitrates on the left, only 1 on the right, so I can balance that out by putting a coefficient of 2 in front of my sodium nitrate. Similarly with my hydroxide, I got 2 hydroxides on the right, but only 1 on the left, so I'm going to put a coefficient of 2 there. And in the process, I balance out my sodium, and now the entire equation is balanced. My relationship here is 1, 2, 1, 2 between all of my reactants and products. Now we can begin to answer this question. Again, we're going to start with the amount that were provided in the problem with the 51.63 grams of the lead 2 hydroxide. We were trying to figure out how much or how many grams of sodium hydroxide we needed to make this much lead 2 hydroxide. So again, we're going to work through some dimensional analysis until we get to grams of sodium hydroxide. So first we need to get rid of grams of lead 2 hydroxide, convert to moles of lead 2 hydroxide. From moles of lead 2 hydroxide, we can now compare to moles of sodium hydroxide. And then from moles of sodium hydroxide, we can go to our desired amount of grams of sodium hydroxide. Now, as we look at the relationships that exist in our first conversion factor, you'll have to go to your periodic table. I'm going to speed things along here. 1 mole is going to be 241.216 grams. You can always check my math there using the periodic table. The mole-to-mole relationship is going to come from your balanced chemical equation. Our relationship here is for every 2 moles of sodium hydroxide that you start with, you'll make 1 mole of the lead 2 hydroxide. And then finally, moles to grams, we have to go to our periodic table. For every 1 mole of sodium hydroxide, we get a mass of 39.998 grams of sodium hydroxide. Okay, at this point, it just becomes a matter of plugging this into your calculator to solve. Again, when you think about the number of significant figures that you need in your final answer, disregard all of the conversion factors. We only need to look at the initial amount that we started with. We have 4 sig figs in that initial amount, so we're going to have 4 sig figs in our final answer. And when you plug this into your calculator, you should end up with 17.12 grams of sodium hydroxide. All right, and lastly, it's always a good idea to think about how you could solve this problem via estimation. And again, you can do some pretty rough estimation and still get some reasonable answers here. As we take a look at the amount of lead 2 hydroxide we have, that amount is roughly 1/5 of a mole of lead 2 hydroxide, roughly. Which means that we would have started with, or would have needed to start with, 0.4 moles of sodium hydroxide, twice as much. And then as you think about converting to back to grams, I think it's probably easiest to just sort of say to yourself, all right, we've got about, if we had half a mole, that'd be about 20 grams. So we're going to have a little bit less than 20 grams, which in fact we do, which makes sense. So again, make sure you're practicing this idea of estimating the answer. See if you can do it in your head without a calculator before you start to give yourself a general idea of where your answer might end up.